This is question number 9 of homework 2 for session 3, problem 6-47. So this is a question about we're trying to calculate a present value of a sort of a deferred, it's called a deferred annuity. So by that we mean the first payment will not take place by the end of the year or by the next period. This is a sort of an important example to sort of tell us when to properly apply the formula for the present value of an ordinary annuity, as we talk about in class. The formula that we talk about in class actually can only be applied to an ordinary annuity. So this formula here, so the context for this formula is we've actually used a 5-year of a 5-payment annuity, right? And if you notice, we are calculating the present value at time 0, but the first payment actually is at time 1. So relative to 0, this occurs by the next period. So that's what we call the ordinary annuity. So this formula is only applicable to an ordinary annuity. So that's the first thing we need to understand. And back to the question, what is the value today of $4,600 per year at a discount rate of 10% if the first payment is received 60 years from today and the last payment is received 20 years from today? So asking, do not round intermediate calculations and round your answer to 2 decimal places. So drawing a chart can help us to understand basically the timeline of this setup. So the time is like in this direction. So we are standing here, and this is year 6, and this is year 20. So it's telling us that the first payment, which is back to the setup, it's 4,600. Will take place by year 6, and this continues until year 20. So we will have 20 minus 6 plus 1, which is 15 payments. It's not only 20 minus 6, because if you just get a 20 minus 6, you're calculating you're not including the payment, which is right at year 6, right? So, but back to the situation when we can apply the ordinary annuity, present value of the ordinary annuity formula. As we said, we need to make sure the first payment starts from next period. So that means we need to make sure we're standing here, not at year 0, but year 5. So which means if we apply that formula, basically what we are calculating is this PV in terms of year 5. So we are standing here. But once we get this PV in terms of year 5, the next step to get to the real present value, which is 0.0 here, is simply to discount this present value in terms of year 5 years back, right? So that, but in this discounting, we are only dealing with this one single cash flow. So following these 2 steps can get us back to this present value, the true present value. We can call this PV subscript 0. So now getting back to using Excel to solve out this question. Again, the first step to use Excel to put everything into the right place. So in this case, the payment, which is the annuity payment, is 4,600, right? So that's and we can just add a dollar sign there. And the discount rate, right? That's the discount rate. That's going to be 10%. And the first payment, as we said, is 6 years, and the last payment is 20 years. But the only tell from those two information, we can, as we just did, we just get this 15 number of total payments, right? Total number of payments. So, and then it's, as we said, we first need to get this PV5. So PV5, we just need to use the formula for the ordinary annuity. So we just use the PV, open it, and the interest rate, and the number of annuity payments. That's what this NPER here means. That's also what in this formula, this T, this T here means. And then the next input is the payment. So the rule here is that we want to get a positive present value. So I added a negative sign in front of this payment. And for the future value, we don't have to worry about that. That means it's a lump sum future cash flow. We don't have that. So, and we don't have to worry about the type. So we can close this. Once I do that, don't forget, we're not done yet. We still need to bring this one single cash flow back to the true present, right, to calculate this PV0. So then we need to use the PV function in Excel again, but we need to be careful because go back to this chart. We're just trying to discount this PV5 5 years back to the true present, right? So the number of years need to be 5 now. So it's going to be the same interest rate. Now 5 and the payment. Now we are just dealing with this one single cash flow. So the payment will be 0. And finally, this one single cash flow is this PV5. So relative to PV0, or relative to the point 0, 5 is the future. So PV5 becomes the future value in this calculation, right? So that will give us the final number here. So then we just need to copy this number back. If that works, sometimes it may not works, the format. So maybe I just need to, I think this might be acceptable. Let's check. If not, I just need to get rid of that $sign. Yes, it is. So I hope this is helpful for you to understand first the place that we can apply that formula of the ordinary annuity. We need to make sure that the first payment starts by the end of the period or by the next period, right? So if that's not the case by default, then we just need to move our baseline. Like in this case, we move our baseline to year 5, pretending that we are standing here first. So now we can apply that ordinary annuity formula to get the present value at year 5. But don't forget, we are not standing here, we're actually standing here. So after that, we need to bring this one single cash flow back to the true present and discount this PV5 by 5 years back. And now we're just dealing with that one single cash flow. And relative to 0, 5 becomes the future. So in this second step of the present value calculation, the PV5 actually becomes the future value. Okay, so that's it for this question.